This next talk is being presented by Breaking Grounds. It's Knock Knock Access Control Edge by Vincenzo Ciancaglini and Philippe Lin.
So hello everyone and welcome to this presentation about edge computing, his architectural weaknesses, and how we can exploit them to sneak into your offices undetected. I am Vincenzo Ciancaglini. I'm a senior threat researcher at Trend Micro's forward-looking threat research team, and this research was carried on with me, Philippe Z Lin at Miowski on Twitter, Roel Reyes at Insomniac, and both will be available at the Q&A session, and Joy Costoya and Morton Swimmer. Now, our team, just to give you context, is tasked within Trend Micro to do technology scouting 3 to 5 years into the future, looking at how the technology is going to evolve, how this will impact user behaviors, and how it will impact criminal opportunities and criminal activities. So with that in mind, we started looking not long ago into edge computing, being the new huge buzzword in the market. And just so that everybody's on the same page, with edge computing, it's basically a new, we can consider it as a new computational paradigm where, in contrast with the more canonical cloud computing, where you have your swarm of computers and IoT devices sort of managed and coordinated by a central cloud service, in edge, you got part of the, if not all of the functionality, moved to the edge of the network, on-premise nearby your devices, if not in some cases even on the devices themselves. So this basically means that your usual processing cycle, of data acquisition, data processing, and decision making and actuation happens almost all in the same place or very close. This bears several advantages, meaning that you have, of course, lower latencies. So in all those applications where a response, real-time response is needed, like some factory automation applications, say that you have a robot in a production line that needs to discard samples, those can be taken with a very short delay. You have less network traffic because you're not communicating with an external service. You have some resiliency due to that because you're not dependent on an external network service. And of course, for all those applications where you have sensitive data, you can, in fact, implement data retention on premises. This, however, means that there are 3 what we call new architectural assumptions within edge computing. There are 3 key aspects that needs to be taken into careful consideration when deploying edge applications. And these are, first of all, an implicit trust of edge devices, because of course they are now charged with more responsibility compared to their IoT counterparts, for example. In the case that we'll present here of access control cameras, you have the access control cameras who are responsible for identifying users rather than just acquiring the images. There's a higher need for data synchronization. Ironically enough, since we just said that there's less network communication with an outside service, there's however a higher need of synchronization between all of the devices, because the devices being charged with more functionalities, they need to have a consistent data set between each other to function. Again, in the case of cameras, they all need to know to have the up-to-date user list so that they can know who to let in or not. And actuation on premises, which means that every time you need to activate something, let it be an industrial robot arm or your door, that is not decided by your external service on a data center, but it's decided on-premise by the device itself. In terms of verticals, we've seen edge application flourishing in sort of several domains, such as agriculture and transportation management. So with all that is related to smart farming, real-time collection of data and monitoring of machinery, smart fleets, and the future autonomous fleets, for example. We've seen factory automations, and industrial control systems. Again, the example that I brought of optical inspection of faulty samples in the production lines, cameras and surveillance, whereas, again, cameras now are tasked with performing the actual identification of people, things, and so on with real-time video processing if needed, and elevators and building automation. So, connected elevators, building monitoring, collection of data, and so on. And that was actually the first application that we started looking into until we settled on cameras. And the reason for that, well, first of all, is the fact that while we were trying to actually acquire a smart elevator to do some study on it, we realized that, in this huge sort of heat of serendipity, they actually deployed the edge computing access camera into our offices themselves. So that was a huge strike of luck. But not only that, cameras are in fact, easier to acquire than an actual elevator, for example, or, an industrial controlled robot arm. They are the embodiment of a very critical functionality, meaning they do user authentication, physical user authentication. They are literally the thing that keeps strangers at bay from your offices. They implement a very representative set of edge devices functionalities. They do data acquisition, they do actuation, they do image processing. So they are fairly representative there. And they sort of represent what we call the user experience flow. What do I mean with that? Basically, take a comparison between IoT access control cameras or cameras and edge access control. An IoT camera is usually a low-power device. It's responsible only for doing acquisition. It sends the data to a central server that takes care of making whatever decision, object recognition, face recognition that's needed. So you have sensitive data that transits outside your premises. They're not responsible for the actuation usually. And because of that, even if you have misconfigured devices or faulty deployments, the stakes, they're not zero, but they are fairly low. What we've seen, the worst that can happen there is that, you get a camera with the default password that's the same for every model and that gets exposed to the internet. Well, you happen to end up on shown images. And the worst that could happen is somebody's going to snoop on your front porch or on your office entrance. I wouldn't wish it to anyone, but it's not that big of a deal. Compared to that, an edge access control camera has a higher computational power. It performs the acquisition and processing on the device or on a nearby server. It takes the decision autonomously to let people in or out of your office, which also means that, yes, you don't have sensitive data that goes out, but if you misconfigure that camera, you're basically incur the risk of letting people in. And not only that. The main point here is that despite this huge difference, they both just look like a camera. There is no visual clue between an IoT camera and an edge access control camera that the latter is going to be way more critical to deploy than what you've been used to up until now. And that's a very interesting aspect of the whole technology. So with that in mind, let's go break us some cameras. We decided, okay, let's get some cameras, see exactly what we can do with them, if they're secure, and what are the vulnerabilities in there. The usual. We picked up 4 models from 4 major vendors to sort of compare. The first one being a ZK Teco Phase D Pod 7B, whereas ZK Teco, it's actually a big Chinese vendor. We had more than $3.58 million US actually in fingerprint readers alone in 2015, for example. And it offers now these cameras which are Android-based, not an up-to-date version of Android, if I may say. And it even provides a dual camera to do liveliness detection, for example. So it has some advanced functionalities. We then have the Hikvision, the DS-K1T606MF, if you want to try to repeat it after that. Hikvision, it's one of the world's biggest vendors of cameras, fairly renowned, especially in the Western Hemisphere. Europe and US, it's a brand that's fairly known. This camera, compared to the other, runs a customized Linux version and communicates with its central server through a custom binary protocol, compared to the usual HTTP APIs that are exploited by the other cameras. We then have the Telpo TPS 980, whereas Telpo is an actual partner. It's another big Chinese vendor, partner of Alibaba, for example, and he's official suppliers of facial recognition technologies for their point of sales. And finally, we have the MACV Koala. Now, MACV, it's another one of the big three suppliers of algorithms for facial recognition, and, for example, the official partner of the city of Hangzhou of the City Brain project. So this just goes to show that this is not just, we didn't go for some niche product from some obscure vendors. These are big players on the market that have a huge history of providing access control products to the industry. And, these are their latest iterations, basically. So, another word of caution, what we'll be showcasing here are not really, we didn't focus on try to attack the facial recognition aspect of the camera. I mean, if you want to know that facial recognition cameras are insecure, well, that's known. I mean, you can attack the algorithms, and it's not what we're going to show here. We're not going to show you that there's a setting that you can set to 0, the lightness detection settings in most of the cameras, and just authenticate with a picture. You can, but it's not the point here. The point here is to use the cameras as an example of how the three aforementioned aspects of, again, device trust, device synchronization, and actuation on premises, when these aspects are not properly implemented, they can be exploited to attack your deployments. And many of the attacks that you'll see, and many of the flaws, don't actually just apply to facial recognition cameras. This is just a very high-stake example, but they could very well be applied to pretty much any other edge application. So that's a fairly important point that I wanted to make. So focusing on the first one, implicit device trust. As we said, edge computing is designed so that you trust the devices that you that you deploy. I mean, you are going to set some cameras that are going to sit outside of your office and are going to keep people outside. You are going to set some smart farming equipment that's going to monitor data without your direct supervision, that's going to be out in a field, miles from you, for example. And they are devices that are charged with more functionalities than their IoT counterpart. Access recognition cameras, for example, not only let people in, but they are also responsible for registering new people. They are also charged for deleting users. Like all the user management part can be performed by the camera itself. And if you think in other domains, you've got your smart manufacturing sample analyzers that autonomously checks your products and discards the faulty ones without you having a direct supervision on it. And so the question is, it's straightforward. What happens if you own a device, or what happens if you can impersonate a device, given all the trust it's given? So we went and checked basically what happens, for example, for user management. Basically all of those cameras, when you register a new user to your system, you do it through the device, which takes care of taking your picture for both your profile and for your profile picture and your bio picture that will be used and compared for the facial recognition algorithm. It communicates eventually with the management server that takes care mostly of just propagating the information and updating the other cameras in the system. And that's it. So we sat there with our, trusty Wireshark on the network, and we figured, okay, so what happens when you communicate with the server? Well, it so happens that, for example, in the ZK-TECO case, ZK-TECO communicates through an HTTP API with the management server, and use that API to notify it of any new user created, user deleted, and so on. And as you can see here, first of all, it's absolutely unencrypted. And there are two key pieces of information that you can get from the traces there. One is the serial number of the device that's used to validate, at least partially, your API call. And the other is a session token that once you grab it, it's absolutely reusable. Which pretty much means that with these two pieces of information, all I need, it's basically all I need to do a curl request to the same server, of which I know the address because I just seen in my Wireshark traces, and ask the server to, by impersonating the device, ask the server to create new users, and so on. So here's a small video, for example, showing you what I'm talking about. What you see there is the ZK-Teco user management interface running on a local server. We've acquired those two pieces of information, as I mentioned, and now we're making a call. We've done the API call with curl. And all of a sudden, we just created a new user just right there without really anybody noticing in the system, with a bogus name, no picture for now, and it's an ordinary user. Now, you might have noticed that I marked this, sorry about that. You might have noticed that I marked this privilege equal to 7 parameters. That sets the privilege level for the user, and it was sort of a crappy foreshadowing of what comes next. Because of course, once you created your user, if you increase that parameter to 14, not only you are creating the user, but you're creating an admin. Just by changing one parameter with the two same pieces of information that will be allowed to enter your premises and alter your database and perform administrative tasks over there. You can also do many other things like updating user and facial recognition pictures to the system just with the exact same API call, unencrypted, unauthenticated with the reusable token. So for example here, and again, this would have been much more interesting if it was done live, but we have to deal with what we have. We are doing the same API call, passing some binary data with the user picture, and all of a sudden you can see that the little panda in the bogus user that we created, which could be really any user in the system, has become myself. So why creating a new user basically? When you can even just change the facial features of an existing one. And not only that, in the profile, you have some biological template quantity. So you have fingerprints, you have face templates that will be used. So we can even change those. With the exact same command on this bogus user that I just decided to impersonate by uploading my profile picture on, I can now perform another API call, whereas I will not upload my profile picture, but I will upload my bio picture, which is the one that will be used for the authentication. So you don't even need to actually create the user there. You can just take an existing one and just change his biometrics to match yours, which basically gives you all the permission and all the access to that very user to enter the premises. So we just run the thing. We now should be opening the profile for that user. Now you see that there's a new face picture, and that face picture is myself. So I now basically just got access under the name of Mr. Bogus to whatever department he's allowed to get in. Now let's talk about the device synchronization aspect. Again, edge devices need to keep a consistent knowledge base to perform their tasks autonomously and coordinated. In the case of cameras, it's the user base, but in case of farming, smart farming might be information related to the fields and to the activities. I mean, there could be many other cases. In order to support this, as we've seen, there usually is some management server that's either a centralized cloud service or it's an on-premise machine that you keep there that's responsible for getting information from one device and spreading it to the others so that they can be consistent. And of course, as you saw, there are APIs to do that. And of course, just like we saw, the question is, what else can we do if the API's endpoints are not authenticated and the connection is not encrypted? So we cannot just create users as we just showed, but there are also other interesting things that you can do for the ZK-Teco, for example. The fact that the API is unauthenticated, unchecked, and absolutely not rate limited allows us also to just do a brute force and harvest all of the user profile pictures or the user bio pictures on the system, pretty much for every one of your employee, because the user pictures are available at this URL with the only identifier being the PIN of your user. And so you can just brute force and go from 0 to 1 million and get all the pictures that are there. Not only that, if you're really lazy, actually, you don't even need to bother doing a call, because the way the system propagates the information is by device polling. So, sorry, every periodically, the system will just send the updated database of new users, or actually, not of new users, of every user in the system. The full updated database will be sent to every device in the network. So if by mistake you're sitting on the same network of the edge devices, you don't really even need to do anything there. Just sit there with a Wireshark open, and eventually you're going to get the full information containing user ID, passwords, which are not encrypted, user pictures, bio pictures, time zones information. You can see their holidays, all sorts of information about when the user is supposed to be there or not. There's a whole bunch of information that basically just exfiltrates itself. Other cameras, fortunately, have more sophisticated system for authenticated. So the telpo camera here also provides a centralized cloud service to do the device administration. It's a subscription service. It costs more or less $10 per device per year. If you're not interested in using it, you can actually just license the facial recognition algorithm and sort of develop the management application yourself. That's doable. But as you can imagine, small, medium businesses might prefer relying on the application because, it's there, it's available, so why not? Now, this application has some APIs that are somewhat authenticated, meaning that to access those APIs, you need a session token that fortunately expires after a while, but that can be retrieved through an additional API call that only requires a device serial number. And by that I mean the serial number of any of the devices in your deployment. Where is the serial number, you ask? Where, if you take your camera and you flip it, you can find, first of all, you can find some exposed wires that should not be there, because two of those wires actually will open the door the camera is attached to. But most importantly, you find your serial number right there. So let's see how that actually works. We got the serial number because, well, we walked by your office and there was a camera there and somebody didn't really screw that in the wall very well. So now with that serial number, I can just go on faceapi.telpocloud.com, which is something I don't even need to sniff because it's the default cloud service domain name. I do a first API call to get the secret and device password, the client secret. With the client secret, I can get the access token with an additional call over there. The access token, as you see, will expire in 1 hour or so, after which I can just get the new device token basically. And now with the device token I can do a whole bunch of things, such as tell the backend that the device is going online or offline. There it is. I can dump guest users, which is very useful if you're doing social engineering and you're trying to infiltrate your premises, because why would you create an additional user that nobody knows when you can just impersonate a guest, which by definition is somebody that's going to walk out after the day. You even have this QR code right there that you can use to generate a badge. You can list the deleted users, which is also something very useful when you're doing social engineering. Knowing who just got fired from the company. You can download employees' pictures, of course, because why not just exfiltrating the full database with all the faces of your employees in your company? That's not going to create any problem, right? And that's just a wget command. You can add a fake attendance record, so you can say that somebody was there at the given time and date. You can create a new users, so like this Joe Kazanayan that's being created there. You can list the employees in the DB and get their numbers again, because why just getting their pictures when I can get their mobile number and their name and whatever other employee information is there. And of course, I can add a user. So there we just issued the command. This is the Telpo Cloud interface, which sort of performs the same task as the ZK Teco interface that we just seen. We are now logging in the interface. And all of a sudden, our Mr. Joy Kazanayan, with the face of our colleague Philippe Lin, appears in the access record. Of course, there's an absolute lack of anything related to server pinning from the device, client certificates, like any sort of a verification, it's absolutely missing, which means that doing a server impersonation can take no more than 30 lines of code. Here is an example. You can write a simple server like that because you're basically just running REST APIs, and then through our poisoning, you can just instruct all the devices to connect to that one instead of the real server, and that allows you, to again send arbitrary updates to your cameras, update new user pictures in case you needed yet another way to just change user picture, harvest camera logs, which could be very useful in case you want to sort of learn the behavior, your employee patterns and behaviors of a company. You can even impeach and delay auditing. I mean, there are, of course, systems where you have a centralized server or an external service that can do anomaly detection, for example, and analyze your patterns and see if there's something unusual. But what happens if you just stop sending them logs, or if you delay them? You can actually delay finding any anomalies in that access. So with that being said, moving to the third assumption, architectural aspect of edge, the unsupervised actuators in device proximity. We've said it, we'll say it again. Edge devices are the one in control of the actuator directly. They don't usually require supervision from whatever centralized service. They act autonomously. And if they are not directly involved with, opening your door, they are controlling whatever actuator is there. Which then begs the question, why am I even bothering with the camera itself if I can just attack the actuator? In the case of optical inspection on a production line, why would I bother tricking the camera to think that samples are faulty when I can just attack the robot arms that are going to discard all of the pieces, basically? And with that in mind, the MACV Koala provides a very good example. MACV Koala sort of has a different architecture compared to the other three cameras. Compared to the others, it's not just a one-device system. It's a three-tier system where in your premise you will have usually a edge node, Dell server and so on, to which you would connect either your MACV Koala, which is in fact just a Samsung tablet, or external cameras that you might already have deployed, and you will use them to actually do the image acquisition and the facial recognition in that case. And you have a third component, which is the network relay, who is the component that actually controls the door. So your edge node gets the image, in fact, from the camera, makes the decision, the server is on the premise, so it's your edge node over there, and if you're authenticated, tells the network relay to open the door. How does it tell it, you say? Well, it just uses a TCP command on a port with no authentication, no encryption, and nothing of sorts. Which means that if you know the IP address of your network relay, which you can very easily know because if you remove the Samsung tablet from the wall, for example, you're left with a USB-C port that connects you directly to the network, which means that you can then do network discovery right there or talk to the network relay directly. And once you know that IP, all it takes is your netcat command with ON1 and you're opening the door. Just like that. And that is without even bothering and tampering with adding user or tampering with the camera or changing its settings and so on. You're literally just controlling the network, the network relay to open the door. So with that in mind, what do we make of all of this? First of all, this is a sort of a summary table. Now, we showcase some of the attacks. This is a more comprehensive table of all that we really checked. I mean, we even checked for the hardware security of the cameras, because again, those are devices that will be left unattended on premises. Do they have exposed ports? Do they have exposed cables? Do they run a hardened version of the platform? Turns out they don't. Again, all of the 4 cameras have an exposed USB port, either Type A or USB-C in the case of MacBook Koala, as I mentioned. Most of the cameras, like 3 out of 4 cameras, are running a version of Android, which is not a recent version and has no hardening in particular. The Hikvision is running a custom version of Linux, at least. Other notable thing, well, of course, with the USB port and running an Android version, it's very likely, and for some cameras, it's in fact possible to do side loading of applications, which opens the door of way more new attacks. It's very possible to do man-in-the-middle attacks in most of the cameras because, again, they are not running encryption or certificate checking and so on. Of all of this, and again, what sort of stood out a little bit was the Hikvision, that, again, at least it's using a binary protocol, which adds a layer of obfuscation, but it's not encrypted. So it really just sort of delays the inevitable because it takes a little more time to do some reversing of the protocol. But, it's not encrypted. It's there for the taking. At least the Hikvision, has a 3-way binary handshake with the server. That's very hard to crack. So doing request forgery to add new users and fake user administration, it's quite hard. The telpo sort of verifies the SSL certificates at server level. So, there's that at least. And for example, for the actuator attack, whereas the MacBook Koala, has a really terrible implementation where you just need to have LAN access to the network relay. In the others, you are somewhat secure as long as the cables are, deployed properly. Be very careful on not exposing cables there because, again, opening doors takes just the 12-volt signal on your wires, pretty much. So this is sort of the situation. Of course, we've done responsible disclosure of all the flaws that we found, and everything was communicated with the manufacturer last year through the Zero-Day Initiative program. So at least on that point, we've had some fixing of the different issues that we found. And, to conclude, I'd like to take a couple of minutes just to rant about the situation because, again, edge devices have this sort of double-edged aspect that they are devices that put a lot more responsibility in the hand of the user without really communicating it visually. You take your edge camera and there's really no main difference with the camera you had before. The fact that once you had a camera that would take a picture and send it to a server that will then make the decision, and now you have a camera that takes the pictures and makes the decision itself. I mean, they're both just look like cameras, but in one case, you are way, way more responsible as a customer of what you are doing. And as a vendor, in one case, you were basically selling a product that, if misconfigured, would at worst be ended up on Showdown with some funny pictures. In the other, would let people in the premises of your customers. And the other thing that really struck me is that we didn't, by investigating all the device, we didn't really found anything that was a new cutting-edge vulnerability linked to some corner case of this new technology. I mean, is it possible that we're still talking about the lack of HTTPS in 2021? I mean, how comes? It's something that we're dragging on since the 90s, and basically what we've seen happening is that every time the media change, every time there's a new buzzword that exploits HTTP, somehow we seem to forget the best practices. I mean, we went from World Wide Web, where we finally had encryption there, to mobile web, in the early 2000s, and all of a sudden people forgot about HTTPS back then. We strove to put HTTPS in mobile web, and all of a sudden we had mobile application, which were not mobile web anymore, except that they were written in HTML and they would communicate with servers through REST APIs. And all of a sudden, the REST APIs were not encrypted anymore. So we worked on that, and there comes IoT with devices communicated in an unencrypted way with the exact same servers. And now that we're sort of fixing IoT, there comes Edge, which drags the exact same problems. So that's why, you know, this aims to be really an awareness talk, because again, these problems in technical communications are not just problems related to facial recognition cameras. They're not just problems related to letting people in your office. They are problems linked with the edge architecture itself. You could see that if those cameras were old IoT cameras, you wouldn't have all these issues of user forgery, client forgery, user authentications, and so on. So there's a huge need of awareness on these three edge assumptions and what it implies to do a deployment of edge applications from both the users and the vendors that provides the products and they put them to market. So possible mitigations that we've seen here, we try to arrange them, you know, around these three aspects, and some of them really feel so trivial telling them here that really makes you wonder. You have, you know, secure your network connections, of course, or at least make sure and verify that the connection of your edge device to whatever external service is secure and encrypted, and demand your vendor to do that. Even better, network isolation for the devices. I mean, I'm talking about sitting on the same network, and, you know, people might say, right, but how likely is that? That might be more likely than one thing. I mean, having critical devices sitting on employees' network is nothing so unusual. Check the hardening, make sure that the cables are protected, make sure that the platform is up to date. Because again, these devices usually exploit some Android version that might not be up to date with the latest patches. And of course, constant auditing for whatever undetected attack. Device synchronization, of course, API should be authenticated, and that goes to the vendors, but also to the customer to make sure, you know, and demand that the API be authenticated, that you get certificate pinning in place. Again, feels like network security 101, but it feels that people forgot about it. And of course, for all of these actuators, you know, extra auditing, make sure that your cables are carefully deployed and check on those installations every now and then. So with this final rant, I thank you all for the attention. You can find our full paper on the research at the address below. And I hope you enjoyed it, and thank you.
We're waiting for questions to come in through the chat. If you are watching this, please join the Discord and ask questions in the Breaking Ground track. Looks to me like Vincenzo is doing a lot of the talking. So do you mind introducing yourself and quickly talking about your role in this presentation?
Sure, thanks, Phil. So my name is Philippe Z Lin, and I'm part of this research, mainly doing the embedded jobs, like tearing things apart and never putting them back, etc. It's much fun doing this research.
Yeah, I wish I could do that. So, you know, sounds to me like you were doing the hardware side. What was some of the hardest part of of doing this research?
Yeah, that's a really good question. So since we have 4 vendors and each vendor have like different implementation of this whole protocols, well, we have to restart the research process one after another. And for example, for the telpo thing, the telpo camera that we have torn apart, it's server paint, which means everything is in HTTPS, and you can just man in the middle proxy to capture the networking flow. So yeah, we once thought it's one of the most secure products that we have studied. But then it turns out, thanks to the debugging log, they have left the very comprehensive debugging log on. So once I get into the Android, which is not locked at all, everything's there. So I can try to imitate a server and grab everything out of it. And For the MACV, it's quite interesting because actually we have hacked everything on their edge server. So they have, along with the camera and the face detection module and the actuator, they have shipped one edge server, which you're supposed to install in the basement of the residential area. And we have actually hacked all VMs because they have used a hardware key to protect the server, but they forgot to encrypt the hard disk at all. So I just take the hard disk out and connect it to external USB to SATA converter, and everything is read out.
Wow. Great. That's very secure. You said the both of you did multiple different devices. How did you get your hands on the devices? Did you just approach the vendors and say, we'd like to do this research, or did you just go buy them off the shelf? Like, how did you acquire these?
Actually, we put them out of the shelf. And for MACV, because MACV is a little bit more expensive, our company asked them for a demo, and we really wanted to use it until we find this vulnerability.
Oh, actually, that leads me into a nice follow-up question. Obviously, you looked at this product before considering to deploy in your environment, but how often do other enterprises look at these kind of edge devices before they put them on their networks?
I think each enterprise might have their internal procedure to assess the security of the devices, but to my best knowledge, probably that's not. There's no open standard, or there is an open standard in each and every country, but people are just barely following them word by word, which means you just have a list and you check, and that's all. So.
Yeah, so they're not as secure, and no one's looking. So what would you say would be the top 3 things that vendors should be doing? The vendors that push out these devices, what are the top 3 things that you would recommend that they should be doing if they're watching this talk?
Yeah, just like what we have drawn in the conclusion, it's like first you have HTTPS. That's the least thing we can ask about. Second, you have server pinning and client pinning. Server pinning is just like Telpo. It gave us a really hard time trying to read the flows. And client pinning makes sure that we cannot just fake the server. And hardening the device itself. So many vendors use Android. Actually, I don't know why, because Android is a very complicated system, and you can have all sorts of vulnerabilities. One of the vulnerabilities for phones, for other appliances. So it's very, very hard to always follow the Android updates until the latest version. I would say avoid Android, or you pay much attention to update the framework regularly.
Yeah. How often do these products usually get supported for? Do you know?
Not that often.
Yeah.
That's
fair.
all I can say.
Well, because I know I have some phones that went out of support, so I don't know how often door cameras get updates for their Android OS. Okay, so we understand enterprises might not be evaluating the devices, but if they have these devices on their network, what should they be doing to secure them so that these type of attacks that you talked about could be prevented?
Okay, probably the first thing is to have a Wireshark running on the intranet and make sure nothing is in clear text. If you can read it, hackers read it, of course. And second is to secure the entry points of the intranet cables. For example, as we have seen in the example of MACV Koala, it's super easy. You just pull out the USB-C adapter. No, sorry, the USB-C, and plug it into your MacBook, and you get access to the internet. And something like that is never acceptable.
That's crazy. What have you reported these to the vendors, and what did they say?
Yes, exactly. All of our research undergoes a responsible disclosure procedure,
Right.
which goes through the zero-day initiative that has been acquired by Trend Micro several years ago, and we have set up a procedure like 120 days for the vendors to patch the products, and the vendor said like ZK Techco said it's end of line immediately, and then all of a sudden they have a next model uh, popped up on the market. So yeah, hopefully they have fixed the issue, and Topo is a better example since we have contact with their R&Ds. They promised to fix the problem in the next generation of that products. So I simply believed them have fixed this issue. And McAfee is a little bit interesting. McAfee has had a very big meeting with us, and they have their directors, managers on board, and they released an advisory within 1 month. But
Wow.
it really didn't go. It really didn't go well when we published the vulnerability to the public because there's some fault on us. We didn't tell them in advance that, hey, 1 month expired, so we're going to tell the public what's happening, and they're caught on surprise. So if there's something we can do better, this is one of them.
Oh, okay. This is more of a personal question since I work on a red team. But do you think this is something that red teams should explore as part of their physical security toolkit, like going after these type of things?
I thought red team has been looking after these kind of devices for quite a long time.
Fair. That's fair. So this research was really interesting to me. But where can we find it? Like, is there a blog we can go to, GitHub? Like, where can we find all this research?
Yeah, sure. I will post a link on the Breaking Ground channel. So yeah, feel free to download the white paper. And I guess I have to say thank you for having us here. And it was great to talk to you. And enjoy the rest of the event.
Great. Thank you so much.
Thank you.